Okay, next here. So descriptive. So in statistic, we have two basic ones, the two major. It's kind of like what are you and why are you analyzing? Descriptive statistic as well as the inferential. But then today we're gonna focus on the first one. So sometimes you will see like it is really useful when we try to describe something like how many the gender differences, how many women in this data, as well as how is the average height or a certain gender. So this is kind of like we try to understand one single variable, just one single variable for the descriptive. If you want to understand the whole thing, the whole data, and then you have to keep doing the same descriptive analysis for the gender, for the female, and then you might want to do about the education level. Then you pick the education level again, you try to analyze it descriptively, trying to understand how many percentage of the people fall within this group or within the other ranges. And other statistics are very useful. I'm trying to understand about the causality, validity, the causal relationship, that is the inferential statistics. So the first one that we're going to learn today, descriptive statistics, is actually kind of like a summary of all the information that we have regarding one variable, or maybe you can say a lot of variables. You can put it together and run it once, and then you can get all the information there. So normally we'll use a graph. You can see a lot of times like in the statistics data or report, you will see like graph, tables, and maybe certain numbers like averagely how many people going to use, how many people are going to picnic this weekend, or else we will calculate by the percentages to present our data more clearly, like 25% of the young adults, gender female will heading to Han Kang picnic in this Saturday. So it try to simplify our complex data, because when you collect the data, it's going to be so huge of number, right? MM2. So when you receive the data, it's going to be a really huge data, full of numbers. These are the numbers that we actually did when we were doing the survey, right? Those are your data. So I deleted all the identifiable numbers. So this is your data, and then it's all into numbers. So what you can do is trying to use the descriptive analysis, trying to make a summary, make it more clear what information are there. So we often see it with the frequency distribution, as well as the central tendency and the dispersion. So the second type that we next week, I guess, inferential statistics is about the prediction. We try to predict something. It is more likely to relate to the hypothesis, trying to predict something, make assumption between 2 or 3 variables about a population based on the data that we collect from a sample. It is more likely concerned with the data that how to have certain conclusion that we're trying to predict, and then we use the data to analyze using the inferential statistics, and we're trying to get the conclusion about that assumption about that population. Things that we'll use inside hypothesis testing, as well as looking at the confidence intervals. And sometimes if you like to look for relationship between 2 variables, how is this going to affect the other one? We'll look at the regression, which will be the last part of the whole lecture. I mean, not today. So first thing, describe the data with tables and graph. We know a lot, right? You can do it actually in through the Excel and everything. A lot of software actually supporting there. So, but in the data or the research or the data statistics, so we have 2 types of data. One is the categorical, the other one is continuous. So first is the categorical. It's category, right? So this is the simplest way to present data. Summarize our categorical data is using the frequency table. This is what we call frequency table. It shows you the frequency. How many times this case or this item or the thing that you're trying to measure occur. How many times? All right. And this table can also include the relative frequency. We'll show you the tables in the next one. And then you can actually make it more visualized using this frequency table to make it a bar graph or pie diagram. So example here, let's say a manufacturer of a radio has plants in California, Arizona, and Texas. Then we have a sample of 25 units here, 25 unit radios here, randomly selected from a computerized database. And then we're trying to understand like which state produce which radio randomly. Okay, we select 25 of them. So you can see like California, Arizona, or Texas. So it's a lot of information, right? Or you don't know like, I need to count one by one or something. So you need to summarize to reveal certain information here. And then you create a frequency table. Just create one. So state here, you can have 3, and then how many times it appears, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you count it. And then Arizona, and you count it 8 times. Texas, and then the relative frequency will be the percentage, each of them, and the cumulative, of course, is the one that you add up everything. So then you can turn it into a bar graph, right? Frequency as well as the state. Now, look at the bar graph here is that there are spaces between the bars, okay? When there are spaces between the bars, it means that you are doing a categorical. When there are no spaces, it's called histogram. So this is a difference between the categorical as well as continuous. Bar by bar, the blue color, and then you have the white spaces, bar, and then the blue, and then you have the white spaces. Those are for the categorical. Pie diagram as well. We can also do a pie diagram like this, of course. Now, here comes to our quantitative data, which is kind of like the continuous data. So, but somehow, sometimes, some quantitative data can be also presented by using the bar graph. Okay, why? Because when we're trying to measure it, and then your data can be a discrete data, such as counts. So your frequency table as well as a bar graph could be used for this one when you're summarizing. And then each number here is treated as category. Also, why is this? Because when you look at the, for example, is the hours of the social media use or the TikTok use, you go by 1 hour, 2 hours, 3 hours, 4 hours, right? So those category cannot be suffer. Like I want to put 1 hour first, and then 2 hours, and after that one jump to 7 hours. The next one for my bar graph will be 6 hours. You don't. But when you do the bar graph for the categorical variable or the categorical data, you can switch. Suffer it. You can put Arizona first. It doesn't matter. Or you can go with Texas first. It doesn't matter. So you can just suffer it. But then when you do with the quantitative data, it has to be going up 1, 2, 3, 4, 5, 6, 7, 8. Or here until 7, right? So the values here for the quantitative could not be reshuffled in the graph. So you will do like this: 1, 2, 3, 4, 5, 6, 7. Keep going. I have the sequence. And the rest are the same as the categorical data. Then you can do the bar graph. And here as well, you can see the frequency is also following the going up number, 0 0.1, 0 0.5, 1, 2, 3, 4, 5, as well as that's the frequency number of the people who reported using 1 hour for the TikToks are like 4 of them, right? Using 2 hours are like 5 of them. So, and then going on to the left, is 1, 2, 7. So that are the hours of the TikTok, and those category cannot be shuffled. So you cannot put like 2, 1, 3, 4, 5. So normally we don't do that. But in this case, in the bar graph, you can shuffle it. I can put Arizona first, then only California, then only Texas. But here, for this type of data, the variable for the quantitative, it has to be going with the numbers. So one of the example giving the text is this. This is the states with the 2050 violent crime rates measured as the number of violent crimes is per 10,000 population. So we have all the 50 states here. So our N number of observation will be 50. So 50 states, 50 of them. And then you can see here, the lowest value is 0. Yeah, do they have 0? Why is it 0? Okay. Well, there must be something wrong here. This is the source from the FBI. Well, let's check there. So, and how you can do, oh, the frequency. Okay, how you can do, let's say, you can actually make the frequency table using the interval class. So you don't actually go with 1, 2, 3, 4, 5, 6, that's so long. We can also make it into interval class. For example, 0 to 9, 10 to 19, 20 to 29. And those are the interval that you can see and keep going on. So for each class, we will record the frequency that falls into that intervals, okay? Fall into the range or intervals, as well as how is the proportion or the percentage, and then you can calculate this is the frequency table for a quantitative data. And you have to make sure for the intervals class is that it has to be mutually exclusive. Because a lot of times, people, when doing the survey, they will ask people, or maybe they create the data, they will put like 0 to 10, 10 to 20, 20 to 30. A lot of times it happens. So you have to remember it have to be mutually exclusive. Because when a state is at, if you put like 0 to 10, 10 to 20, 20 to 30, if a state has like, has a number of 30, where should you put 20 to 30 or 30 to 40? So it has to be mutually exclusive, meaning that that data or that number can only fall into one of the category or the one of the interval class. And here it comes. This is how you create your frequency histogram. So, well, histogram is something that we don't actually we draw it, well, you know, like we drew it when we are in the elementary school, but not anymore. So we have a lot of software, everything can be used. And you can see there's no space between the bars. It's so different from what we learned about the bar graph. Bar graph, actually, they have spaces between them. So when you use the frequency histogram, it means that you are actually showing us the continuous category. The other way of plotting the graph or the data, this is less likely to be used. Actually, you're less likely to see this one when it comes to like, you know, like when you have the official data report or something online or something from the government or something, they are less likely to use the plot like this. This is called the stem and leaf plots. You can see there's a stems here and then using the leaf here. So stem and leaf plots actually makes the information, how to say, it has its strength, of course. It's quite similar to the histogram. If you turn it the other side, you will see it is actually a histogram. So one important thing for using this one is that when your sample is small, not that too large until like 500, few hundreds, it's gonna be, you better use the histogram is you have a really huge data. And there is a stem and the leaf. So the stems are the body of the plant, right? And then the leaf, of course, the branches. How it works with the stem here. You can look at the picture here. We have 4, 5, 6, right? And then 3, 7, 8, 0, 2, 5, and 1, 4. What are these? So 4 means the 43, 47, 48. So 4 is the 2 digits number. And then 5 is the 2 digits, the second one, like 50, 52, 55. This is how you actually look and trying to understand about a stem and leaf plot. Well, I won't ask you to draw in the final exam. Well, an example here, but at least you have to recognize an example here. So the same thing that we are using, same thing as the histogram. But the thing is, what we did here, what we are doing here is that we're using the stem and leaf plot. For example, on the first line, the stem of 1 means that only 12 and 13. So 1 on the stem is 10. And then the leaf will be single, 2 and 3. So it's like 12 and 13. And the second row will be the similar thing. The 2 is a 20. So if it is a 0 there, it means 20. If there is a 1 there, it means 21. So 21 has 2, 21, 21, 22, 22, 22. This is keep giving you all the numbers that appear in the table 3.2. Summarize everything. So this is a little bit different from the histogram because histogram doesn't really show you which one is the highest value and which one is the lowest value. Because on the stem and leaf, you can clearly see what are the numbers that we have, which one is the highest, which one has the most coming out appearance, most appearance here, the numbers, and which one is the one that is the lowest. We can also do comparative, which means like we have two different groups you're trying to compare. So there'll be left and right. And then you can do something like gender side by side and the same thing. One is 10, so 15 for the female, 18 for the female, and then 10 for the male, 12 for the male, and 15 for the male, and so on. So now something's not that hard. So graph and tables are something that we use a lot in descriptive analysis, and you, of course, everyone already been understand about that and learned before, and we always see that one coming out in all the books, all the reports, or online or everywhere. So now this univariate analysis is something that we're trying to analyze, and it is the simplest form of the quantitative analysis. Quantitative, we are talking about the numbers right now. And always, it describes only one variable at a time. So what we're trying to understand by using this univariate analysis is that we're trying to understand three things here. One is the distribution. Okay, how your data is distributed and what are the shape? How is the shape? From knowing the shape, looking at the shape, you're kind of able to understand how your data is actually have the story behind. So the second one is the central tendency. We need that a lot to, well, of course, most of the study will have that one. And the dispersion, which is how spread is your variable. When you have one gender is not really spread. When you have a certain variable, how spread are they? Are they gonna be narrow, just focus in one point, or are they gonna be spread out like too many different types of people in a data? So example is like you're trying to analyze the gender. So you count how many males and how many females, and then you get the different types of the answer. Okay, I'll show you. So common tools will be, we use the frequency tables, bar chart, pie charts, of course, like what we seen just now. So here are the graph that we normally will look at. Three big features here. First is the distribution. We kind of see the skewness. Whether the values are symmetry, you can see whether they are symmetry, same size, left and right, or they are clustered to one side or the other side. Okay, like the picture number 2, left or right. And then we also try to understand about the central tendency, which are the most common values, or the values around which the cases tend to be clustered. For example, we try to understand about the mean, right? The average score, we always get the mean. The average people about how. So we're trying to get about the mean. But we also trying to understand, despite just the mean, what about other value? Are they falling apart from the average, or are they actually clustered together at the mean, center at the mean? And the last thing we'll want to look is the dispersion, which is how it is actually spread out. You can see like one is the B, nation B is actually kind of like focused, trying to be together, clustered together, but nation A will be like spreading out. All right, first thing, distribution. The most basic format to present the univariate data is to report all individual cases. Oh, everyone. So we have like 40 something people in the class, 50 people in the class, then we report every single value. Every single. If you have 500, 600 people, the cases or the data, you have to report every single one. And then only you are able to get the frequency, you are able to get the histogram as well as understand about the shape of your distribution. So normally, if you get a histogram, it will also show you how the shape is. Okay, this is quite the same thing. So there's one is a histogram, the other one is trying to draw a line that represent that histogram. Now, three things that really important when we're trying to understand the shape, which are the central tendencies of the value from here. We have the mean. Mean, like mean, median, mode. Mean is the average score. Okay, mean, we call it mean, averagely. So you add up everything and then you divide it by the number of the data set. And then the median is the center and the mode is the common score. So, but then there are three measures that provide different information and we need to be considered about the level of measurement. Remember, we talked about measurement and how is different level of measurement. So when you have the nominal scale, you'll probably look at the mode. Mode is the most common score, and because only the mode is appropriate to understand about the study. Because you using the nominal, you wouldn't have the mean score at all, mostly. An ordinal scale, you look at the median and mode. Of course, we prefer median. And then interval and ratio, we'll look at all of them. And mean is very, very sensitive. So first, mean is easy, right? It's not really hard. So when you have a data set of, why is it moving? When you have a data set, so you will probably just like add up all the numbers that you have. So if we have like 50, 60, or 100 or something, we just add up all the score and then we divide it by the number of, cases. Okay, we divide it by the number of cases, then we get our average score, which is our mean score. If you have like 500 data, of course, you're going to get the mean score as well. It will be really easy when you use the software, statistics software, or else if you use an Excel, it will also give you the number as well. So most likely we use it for interval or ratio scale data only. Not really appropriate for ordinal and nominal as you've seen in the table here. Okay. For examples are the average household income, be dealing with numbers, average hours spent online. And the next one is the median score, which is the center value. Median is the center, is the one that you got it, middle value or the central value. But what if I have like even numbers in my data sheets? Then you will have to get what? Two of them. And remember, when you look at this data, how you're going to get the median number is that you have to arrange them by the number, by the order. So from the smallest one to the biggest one. Then you have to you pick the center value. That is the middle value. You cannot put like arrange it different way, and then that is not actually the middle value. That is some random number. So for the median score, it has to be going with the orders from the smallest to the biggest one. Then you pick the center value. When you have two of them is an even number. If your data set have an even number, then you have to pick the two of them and you divide it plus them, you divide it by 2, and then you got your median score. Not for the nominal data because there are no meaningful order here. Mode. So mode is the one that appear the most. So same thing, you just have to rearrange them in that order from the smallest, from the lowest to the highest or to the biggest. And then you can see which number actually appears the most. Now we can see like 20 has 3 times appearance here. So 20, that numbers is our mode. So mode equals to 20 in this case. What if I have 2? If I have 2, yes, it is possible. Sometimes you have 2 or more modes value that coming out from a data. But sometimes you actually will get none, no more at all. It means that everything will be the 1, 1, 1, 1, 1. Everything will be a single number. Then you wouldn't find something that is appear or occur for more than 1 times. Everyone is even, everyone is equal. Maybe all the numbers appear twice. So, and then what if I have 2 model, which is what we call bimodal distribution. Most of the time, if you have 2 numbers that keep coming out for many times. And this happens when we're trying to measure something attitudes, like there are polarization for ideology. You will see like one people that support the other way, the other one is support the other way. That by that time you have 2 modes most of the time. You can see there will be a bimodal distribution. We have 2 peak here. So it means that we have 2 bell shape. So The next thing is central tendency. Because of the value here, we are able to look at the shape of the distribution. So the first one is called normal distribution. On the left there, it's kind of like a bell, right? Like bell shape. We call it bell shape. Sometimes bell shape distribution or normal. I don't like my PPT. Why keep going on? Why? No idea. Anyway, it's symmetry. Oh, often symmetry. Left and the right, they are the same. Okay, and if you look at, if your data that you're going to analyze look like this, it means that all the numbers, all the values, all the people that we answer the questionnaire, our answer that responses that we made actually quite similar to the average score, the mean score, because everyone is in the center. You can see the peak there. So the peak is here. The peak is the most number, maybe here, the number of students who answer this question. So that peak is here. Everyone is gathering at the mean score. In this case, you can say like the mean, median, and the mode, they are actually quite equal to each other. The second type is U shape. So it's kind of like the other way. The U shape, you can see U here. So we have two peak left and right. It means that we have a lot of people answering and have the response within these two ends, low ends and the high ends. And not much people actually answering close to the middle one. And in this case, our mean score will be influenced by the extreme values because, you know, like so high, like extreme scores, a lot of people actually score like 5 on that question, and maybe 30 or 20 people will score like 1 at the same responses, leaving like maybe how 5 people will be like randomly 3, 4 number like this. So in this case, median will be used to interpret the data. Why? Because it will be less sensitive to the extreme values than the mean. The other one is bimodal distribution, two peak, the one that we talked just now. When you have like two modes coming out, normally you will see that your distribution will be the bimodal, two mode here. So you have two different peaks here. So two bell plus U. So indicate that there are two distinct cluster or groups within a data set. Maybe let's say we collect the data from a group of people. When you have two modes, means that there are two different types of people extremely holding a certain attitude A and the other group holding a certain of attitude B. Two different types of people that is obviously having, like there's a pattern in your graph or the distribution. So the mean and the median, they will fall between the two peaks. Mean and median will be between them, these two peaks, okay? And then the mean will be more sensitive than the median in this case. And so when you're trying to report your data, trying to report what you found in this data, you are more likely to use the median score rather than the mean, because mean is so much sensitive in this case. So now there are also other shapes of distribution here. First is the symmetry one, which is the normal one, no skew, okay? The center one, the B, no skew. In other words, it's like the mean, median, mode is kind of like similar to each other, falling in the center, so that you can get so symmetry distribution here. And then the other one is called right skew. Right skew on the left there. Right skew. If you got this graph and then you just quick look at it, you don't really have to look at other things, look at the graph, you click the histogram and you found like, oh, my histogram looks like this, you know, the peak is on the left, close to the 0 there, then you'll know like, okay, my mean is actually on the right side. My mean is bigger. When it is on the right side, on close to the X there, then when your mean is close to the X, it means that it is bigger than those who actually far from the X-axis there. Here's the X here. So if a mean is falling in here, it means that your mean is bigger than the median, than the mode, okay? When you go through here, number is getting bigger, right? Here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It means that when your mean falling here, Your mean is likely, very likely to be bigger than these two. So here you can see the mean. Where am I? The mean is bigger than the median and bigger than the mode. The other one is called left skew. So it's the other way. So it means that it is negatively skewed. So your mean will be close to the 0 here. Here is 0. Starting point is 0 here. Okay, 0 here. And then 1, 2, 3, 4, 5. Maybe, okay, my mean is 5. And then after that, maybe 8 is my median. And mode will be here. Mode is always at the peak, okay, because mode is the one that keep coming up. The occurrence is high, so mode is always at the peak here. You can see mode is always at the peak here. The peak is the mode, and median will be the central value. And then you will have to see how is your mean score be. So the other way is the same thing. If you have the by model, then it will be the similar things. One peak will be higher than the other one. So now talk about the outlier. Outlier is the one that we trying to avoid. That's why we say why is the mean score so sensitive for certain types of data and certain types of distribution? Because sometimes we have some outlier in our data set. So which is there will be a value that is unusually high or too low compared to the rest of the data. You see, it actually falls far outside of the overall patterns of the distribution. So if you have an outlier that have a really, really extreme score, it can actually affect your overall distribution or the representation of your data center. Look at here, example A here, we have the data set is fine, right? 3, 4, 5, 6, 7. You know, our mean is 5. And our median is 5 as well, okay? At the center, 5. When we look at the data set B, we have 3, 4, 5, 6. We don't have the 7 now. We have the 100. What is our mean score right now? 23.6. Just one outlier value can actually change our mean score so much. That's why it is unlikely to explain the overall data, because when you want to look at the data, you can't understand about the data as a whole as an averagely, you can see the patterns. But when we have an outlier here, you have to be careful to interpret them, because these single value affect the overall data distribution, and then your distribution shape will be changed because of one single value. Your mean score will going up so high, and that the same thing, right? Your median score is still 5. So the median is still 5 there, but then your mean will be moving towards my right side, okay? Okay. So talk about mean and medians. We talk this a lot. Mode is something that is not so sensitive. But then mean and median, especially the mean. Mean is really, really sensitive and about the data. So both mean and median, we try to describe the center of the distribution. Depending on how your data is coming out, you actually will have to decide like whether you want to report about the mean or it's better to report about the median. So when reporting the result, try to use the median when your distribution, you know, is extremely skewed to the other way, when your shape is not that perfect. Like the perfect one is the bell, okay, bell. So because they should have certain values, some values are really, really extreme outliers, that means. So, and then try to report about the mean when you actually have this symmetric one, because there will be not much outliers or the extreme values that appear in the data. So dispersion is the other way that we try to look at the distribution as well when we have the data. So it refers to the amount of variability, or how it is spread out. How is the variety within the data? How huge difference are those data I collected? So it describes how data values difference around the central value. And two common things that we use to measure, one is the range, the other one is the standard deviation. So range, no, it's not. Range is about how spread it is in my data. So it is differences between the largest and the smallest observation. And standard deviation is how much each value differs from the mean. Okay, we take the mean at the center. Okay, let's say we have like 50 people, and our average score is maybe 30. Our average score is like, oh, here, our average score is 80. Okay, 50 people, our average score is 80. Let's say 80. And what about other people? Everyone here, 50 of us. Are we going to, our score, are we going to close to the 80? Let's say what is the score here? Oh, let's say your, okay, quiz score, 80% is the average. So everyone have different score, right? We are not going to close to 80s, but how far are we? My score, my quiz score, how far my score is actually away from the mean score. That is standard deviation. And here is the formula for calculating it. Okay, look at this one. Let's say we have the 5 people. We have 5 score for the quiz. My class is small, and we have 5 students, 76, 74, 86, 84, and 85. My mean score is what? 81. This is my average. Well, averagely, this class, they are doing really good. We have like 81 in average. So you calculate it, okay? X minus the mean, each number minus the mean, okay? So 76 means that I use, maybe I have student A, B, I have one A, B, C, D, E. Okay, I have student A, B, C, D, E. So student A, 76. So I use the 76 to minus the average mean score. So do the student B, C, D, and E. I use every single value to minus the mean score, and then I got a number here, minus 5, minus 7, 5, 3, and 4. Then I have to square it up, become 25, 49, and then I add it up, become 124, and I use the formula n minus 1. What is my n? My data, I have only 5 students, right? Okay, 5 minus 1. Then I will get 31, and then I got it 5.57. This is my standard deviation. What I'm trying to see is that in an overall, how far my data is away from the mean score. Okay. And this is the mean, how far away is a per unit. We count it by per unit. I'll show you later. And this is second class. You can see like second class is different. Like here is like quite like similar to each other, right? 76, 74, 86, 84, 85. But here in the second set, the other class are kind of different. We have an extreme score a little bit here, like 53%, and then the other one is so high, it's 95%. Then we have some 62, 99, and 96. One to the end is like scoring so well. The other side is like, I need to work on a lot. But we do have the same mean score here. You can see it. 81 mean score, both are 81 mean score. However, when you look at it, you'll be like, oh, so these two classes, if you just look at the mean score, you'll be like, oh, both classes, they are doing very well. Averagely, the students are scoring about 81% in the quiz. But when you actually look at it, there are certain people that actually far from the mean score, okay? So the standard deviation for the data set B is 21.72. So you can see like two difference. Okay, so what does that actually mean here? It means the mean for the data set A and B are both 81, right? Everyone, two classes. Okay, everyone is like averagely getting 81, but not really the story. But look at the standard deviation for set A is 5.57. Set B is bigger, 21. Or let's say 21.74. The mean score will tell us where is the center. But the standard deviation will tell us how spread out our data is. So when we have a low standard deviation, low SD, it means that everyone cluster around the mean. Other people like quite similar to the mean score. So when I say like class A, they have like averagely like 81%, right? Oh, quite good, because and the standard deviation is really low. So it means that everyone quite close to the 81% averagely. Okay, so the differences, which we call variability, is low. The differences are not that huge because everyone is close to the value of 81, the mean score. But then when you have the high SD, which is this set B, 21.74, which means that it's quite spread out. The scores that the student have are quite a lot of differences, very different, like 50 something, right? 53, 90, 60. So it's quite spread up, which means that when you have a high SD, there are higher variability differences in that data. Students are different. Okay, the score that they receive are actually quite different, very different from each other. It's not clustering with the mean score, not really around the 81. Okay, I have to go back to the range. So when you look at the range, forget to explain. You look at the range. Range is the smallest and the largest observation, which means that you know, like when we do the data, we have 1, 2, 3, 4, 5, right? When people answering. So not always that people will answer within like 1 to 5, you know. Is the possibility for answering like 50 people here? Everyone, am I going to get the data 1, 2, 3, 4, 5 as well? Sometimes no, because sometimes the 1 is too extreme, people will not select. So it means that my range will become 2 to 5. If people not selecting 2 at all, then my data range will be like 3 to 5 only. If everyone here randomly select 1, 2, 3, 4, 5, then my range will be 1 to 5. So if the range is smaller, you will get a narrow one. So your peak will be smaller. If your range is huge, then you have a really wide one. So now, okay, talk about your assignment number 5. So you will find a file. Let's see. No. If we go back to your cyber campus, you'll find this one, data for assignment. So there is this SAV file, SVV and SPS. So SPS is the syntax we'll open for you. Raw data, you don't really use the raw data. I just keep it like, if you want to use it or something, you can just try and play with it. The descriptive analysis is the data. I already cleaned it for you. So you are likely to directly use this one. And here's the syntax. You won't really actually need the syntax, but just for reference. So the only thing that you actually need to do with your assignment is this one. Okay, MRM02, which is our class. And then how to do it. You can see here assignment number 5. Click on it. Here has the assignment, right? Number 5, just download it. And there should be something like this. So I put everything up, it'll be easier for you. So using the file, the data set file is actually what we did, okay? So using this one, and then I record everything here so that I'll put it online so that later, if you are not familiar with how to use the software, I'll try to run it today so that you can rewatch again this video. So basically the name in the data, I put it like this, but what are the variables actually describes are here. So pick one that you think you want. And then this is not individual assignment. I prefer you to do like 2 to 3 people together in one group so that you can discuss with your friend. Oh, I forgot how to do it. Should we look at these? Or what are these? Trying to discuss with your group mate. So what you're going to do is select one variable from the list above here. Okay, I only have those. So conduct your analysis using the SPSS. I'll show you SPSS, but you are actually, if you're already like being proficient in the R language or the Python, you can also use it for that one. Report the following description clearly. So things that I'm looking for is mean, median, mode that we look for today, standard deviation, range, as well as a histogram. Okay, I'll show you. And I actually extended you're supposed to due on April 30th. So extended until May 4th since we have a holiday. And here are the answer sheet that you can use. You can create your own if you want. Just tell me what variables you have analyze, and then report the following descriptive statistics, mean, median, mode. What are the numbers? Just put in numbers and copy paste the diagram or the distribution here and explain to me what you see from this distribution. Okay, things you're gonna do is like, I also have the PPT on it. Raw? No. Okay, this is the other class. Let me see. Right, variables. So you will see a lot of data here. And then when you look at the variable view, it's too small. Here are the names, okay? Age, female, education, interest, political talk, traditional news, digital news, social media frequency, hard news, soft news, issue news, and then we have the study behavior, perceived knowledge about this class, your physical activities, your social life, your sleeping hours, and then your sleep quality, as well as your English, perceived English proficient. What you're gonna do is you will go to analyze, and then first thing, descriptive, and you go to descriptive again. This is the first thing you can, and then you select one of them that you want to see. Let's see, how is the class social activities going on? Option, you can see like a list of here, you can actually select standard deviation, the minimum and the maximum are these are the range, okay? You can also click the range as well. Mean here, okay, continue. Well, I don't usually click OK for most of the time. Let me open the syntax as well. Syntax. Syntax is kind of like you ask the software what to do. Okay, I already record everything and clean the data for you. So if you're using syntax here, let's say I will just paste. Most of the time I just paste because I don't want to affect my pure data or the raw data as all. So I'll get something like this here. I'll select them, data set, okay. And then I click run. Where's my output? Okay, and then my output is here. So in this case, you can see, can I enlarge? In this case, after I run it, I got my descriptive statistics, 50 people. The range is what? 14. What does it mean? So the range is from 6 to 20. Is it why? No one answering 1, 2, 3, 4, 5, right? I have like 6 to 20. So my range is like from 6 to 20. It's quite wide. Okay. And the minimum and maximum explain. You can see like 20 minus 6 is 14. That's the range. And then it is running from where's your range? Beginning 6 and then end at 20. My mean score is 12.88 and my standard deviation is 3.946. Okay. We still have time to run, right? Okay, now I'll go back to the data. Okay, the other one is that you're trying to analyze again. You go to descriptive statistics, and then this time you go to frequency. Let's select, let's look at people's social media use, social media frequency. You pick the statistic. So now you can select things that you want. Maybe look at the quarters, standard deviation, minimum, maximum, which is the range as well. In here, you can see you can select a lot of central tendency here. Here's the central tendency. Select mean, mode, mean, median, mode. You want to look at the skewness? Yes, let's look at the skewness as well. So continue. I always paste. You can click OK as well. Okay, now you can know all the information about the other class, not this class. So the mean, what's this? Yeah. Their social media use, how frequently? The mean score is 25, and then the median is 26, and the mode is 23. Standard deviation is 3.899, which means the standard deviation is really small, right? everyone is not really have someone that actually using extremely low and extremely low. Everyone just like cluster between in the mean. So you can see like, oh, okay, it's not that much. Students are quite the same when they use the social media. What about the range? The range is 18, 17 to 35. It's still wide, but then still because the standard deviation allow us to understand that people are clustering around the mean, so you kind of know. So here are the frequency table that we have, and then we can use this one to create the histogram. So back here, the same thing again, analyze, and then you go to descriptive frequency. You can click a chart here. What do we want to see? Histogram. Okay, show the normal curve on histogram. Continue. And now we got this one. This will be our histogram. We have a very high mode here. 8 of the student answering the number of 20, 21, 22, 23. So here you can see this is the normal distribution. Well, we have an extreme score here. The mode is here. So the mode should be 20. Yeah, the mode is 23. You can see the mode is 23. This is the one that appear the most occurrence. Okay, so here is your histogram. You can explain how you think about this one. Is it too skew? I think it's skewed to here. You know, when you're trying to draw it, it's like here. So it's kind of like to my left. So it's right skew. This curve is right skew. And then if you're trying to look at the mean score is 25.76. So let's say 25.76 and the median will be here, 26. And then my mean score is 25. Oh, okay, it's not that bad. And then my mode is here. Mode, mean, median. So that's how you're going to work on it. All right. So I also include everything here, how you're going to work on it step by step. So you can look at it from the PPT. Step by step here. Where am I? I will also upload this video. That's why I recorded it at first. And how you're going to do, you paste and then you run the output. For the frequency as well, you can see a descriptive statistics frequency, select one or more variables. Now you can just have fun to see how is the class doing. So you will get something like this. This is some other outputs. So this is like, ooh, here. All right. And where you can actually use if you don't have the software. Okay, here are the PC on campus that have such a software that you can actually access. And two of them are actually in this building. Is it? Yeah, postcode and 159. And then, or else the other one is at B154. For the 159, sometimes they have the class. So make sure you check the schedule at the outside of the door first. You can go to the B154 as well. The B154, it is not likely that all computers have the SPSS. So go inside and check which PC has the SPSS software. Make sure the number, then only you go outside to like check in, right? Okay. Or else you can go to ECC, the same thing too. Not all PC have the SPSS software. Make sure you check which one they have and then trying to use it. If you're using R or Python language, it's fine. Just submit the same thing. All right. That will be it for today. And then I will see you next Thursday or something. So I'll upload this video and I'll send you a link. I don't know where am I going to upload them yet. So that you can look at it, how to actually